Hey everyone, let's solve permutation in a string. Given two strings, string 1 and string 2, return true if string 2 contains a permutation of string 1 or false otherwise. In other words, return true if one of string 1's permutation is this substring of S2. Let's take the first example, right? As you can see, the string 2 is going to be this one and string 1 is going to be this one, and we have to return true for this case. So what is a permutation, right? So a permutation is just the arrangement of the characters in a string, right? I mean, for this case, we can say this is an arrangement. For example, if we have AB, the arrangement they we have then the arrangement of the character is going to be changed, right? For example, if one of the arrangement is going to be AB, and the other arrangement can be BA, right? So this is just permutation is just an arrangement of characters, right? In this case, for so we are asked to find one of the permutations of the first string S1 in a string 2, right? So as you can see, there is, for example, the second string is going to be ED is going to be B A zero. Well, I mean, all the two O's, right? It's going to be this one, right? So as you can see, there is BA, right? As you can see, BA is in this. There is a substring in string two that is one of the permutations of this string one, right? As you can see, BA is in this substring, so we can say like we can return two for this case. So for the next example, as you can see, what if we change, for example, what if we change, like, what if we have here B, O, and they say we have A here and the two O's, right? What if we have string two is like this, and can we find a substring in S2 that is one of the permutations of S1? No, right? There is no one here, right? As there is no one in this. If you take, for example, these two strings, it's impossible. If you take any two consecutive strings in this S2, you can't find you can't find one of the permutations of this one, right? There is no one, so we have to return false for this case. So as how do we solve this problem, right? So one thing you have to understand is a substring is a contiguous part of a string, right? They have to be contiguous. And in this problem, if you understand carefully, if you see things, the length of the length of the string we are going to find in the string 2 is going to be the same as the length of the given s1, right? So we have found a kind of a window, right? So, and one thing we have to understand is also, if you see a permutations of this the first thing, for example AB, for example, if you see them, they are there. If we build hash map, they have the same frequency, right? For example, let's take the first permutation. It's going to be how many A's we have only one A. If we take this the first permutation, and how many B's we have only one B, right? So this is going to be the first hash map, the first permutation as hash map. And for the next permutation as hash map, how many A's we have? We have only one A. And how many B's we have? We have only one B, right? So if you carefully see the things, there there is the characters there is only their order. It's only their order is changing, right? But their frequency is the same. They have the same frequency. So those two hash maps are the same, right? They are identical. So we can use this concept this concept to solve that problem, right? So we can only find a hash map in the string 2 that is identical to the given string s1, right? So that's how we solve this problem. Maybe you can use other like hashing algorithms, like string hashing algorithms, to solve this problem. But this one is just the easiest one, right? You are going to First, you need to know the length of string one, because you are trying to find, you are just trying to find, because you need to know the window lengths, the characters you have to include in your in your substring, right? So once you know that, then you can just trying to find a hash map similar to S1, right? So let's solve this problem, so how do we do is just, let's say, take the first example we're gonna have, and we're going to have this one, and we're going to have a, and there's going to be the two also, right? Let's use two pointers, like the left and the right pointer, right? And first we need to know the length of these characters, and and the length of these characters. We have two characters, right, for S1, and we have to first generate a hash map for S1, right? So the hash map is going to be, how many A's we have. We have only one A. How many B's? The key is key pair, right? Hash map is just a key pair, a key value pair, right? So how many B's we have? This is the hash map, right? Then once we generated the hash map for S1, we can just build a substring hash map, like, and compare it to the two hash maps, right? For example, let's generate a second hash map. Let's say a substring hash map. For example, let's add e to our substring hash map. Let's call it, let's have, it's going to be how many e's we have. We are going to have one e, right? And we are going to move, since the length of the difference between the left and the right is one, we have to move, the right to this position. So because we are going to use right minus left plus one is going to be our window, right? It's going to be our window. So once this is less than, the length of S1, let's say k is going to be 2 for this case. Once, right minus left plus 1 is less than this k, we have to include the character in the right pointer. So let's add I to our substring. Let's say how many i's we have. We are going to have only one I, right? So as you can see, the difference between the left and the right is going to be, since the right is position, the left is at 0 and the right is at 1, the difference is 1 plus 1 is going to be 2. So it's going to be the same as our window length k, right? So as this position, what we are going to do is we have to check whether these two hash maps are similar, right? If whether they are the same or not. So as you can see, they are different, right? So since they are different, what we are going to do is we have to remove the character from the left, right? We have to remove e from our hash map. Then what we are going to do is we have to remove this e. Then what we need to know, what we need to have is we have to remove this e from our hash map. Then it's going to be, and we will move the left to this position, and we are going to have move right to this position. So we need to add d to our hash map, right? It's going to be this one. How many eyes we have? We have. So at this position, we have to compare this to two strings, because the length is the difference between the right and the left is 2, right? So at this position, we have to compare the two. They are different. So we are going to move the left to this position and the right to, yeah, the right was here. The right was at this position and the left is going to be at this position now. Now, for we have to remove I from our substring, because from the left, right? Since it's a character in the left, so we have to remove it because its count is also 0, right? Then now we are going to add b to our substring hash map. Then it's going to be this one. And as this position, we have to, at this time, we have to compare the two, these two, right? These two, we have to compare the two, right? these two hash maps, then they are different also. At this point, we have to remove d from, since the left pointer is pointing to d, we have to remove the left, right? The left is position, so it's moving pointing d. So we decrement the count of d by one, and since it's going to be zero, we have to remove it from our hash map. And we will move right to this position, and the left is going to be this position. Now we can just add a to this hash map. Now, as you can see, we have the same hash map, right? We have these two hash maps, right? These two hash maps are the same, right? They are identical. So we can just, at this point, if they are the same, we can just return true for this case. But if it is impossible to find a substring in this string two, that's if this condition is never executed, so we can just return false, right? So the time is going to be of n, and the space complexity is going to be of n. So let's go to the implementation. So okay, so we need to have first, we need to know, like, let's say k is going to be the length of s1. Let's say S1, and we need to know S1 frequency, right? We need to have S1 frequency is going to be, we need to know, we can just use counter of S1, and string counter is just, we can use substring counter. Let's say it's going to be default dict. Initially, let's say it's default dict, and we can just start from left and for right. Let's say range of, let's say, lane of S2, we have to iterate over S2, right? Then once we have this, what we are going to do is if right minus left plus 1, since it's zero indexed, we need to do this, right? If it is k, what we are going to do is we can just compare the two. First, we need to add in the substring counter, we need to add the character in string 2 of from in the right. So we need to add it to our dictionary. Then once this condition is true, if we found if we found if we found this k window, just we can just this is a sliding window, right? We are sliding a window, like its length is k, right? So if the left and the right is going to be k, the difference is k, we can just compare the two S1 frequency and a substring counter, right? We can just compare the two dictionaries, and if they are the same, we have to return true. But if it is impossible, if it is false, we have to remove the character from the left, right? From this string, substring counter. We have to remove from that, we have to remove S2 in the left. I mean, before we have to decrement this counter by one. But if the count of the character in the left, if it is zero, we need to have it, right? We have to delete it, or we have to delete it from our substring counter, and we have to move the left to this position. We have to move it to the right. I mean. So if it is impossible to find a substring, we have to return false. So the time is going to be of n. Why the time is of n for this case? We are comparing substring, right? Comparing this is going to be, since how many characters we have in English, right? 26, right? Comparing this is going to be 26, right? For it's going to be like we are going, how many times, then it's going to be, we are comparing 26 characters, right? So this is going to be just of one, right? 26 characters, just it's of 26 is going to be of one. So the time is just, we are just, it's one pass, right? It's going to be of n, and the space is, since oh yeah, the space is going to be of one, right? Because how many characters in the maximum we can store in this default dict, and this one, right? It's going to be 26. So the time is going to be open and the space is going to be offline. So let's see if this works or not. Okay. So let me write time. So time is going to be complexity is going to time complexity is going to be open, and space is going to be over, right? Since we are only storing 26 characters, right? Yeah. So only we have how many characters we have? We have lowercase English characters, right? They are 26, right? So the keys of this dictionary is in maximum is going to be 26. So it's going to be over for the space, and time is going to be only one pass as it said. It's going to be so it's invalid syntax. So where is yeah, it's going to be invalid. Okay. Yeah, it's passed for these three test cases. Let's see if it works for all of them. Yeah. So as you can see, passed for all the test cases. If you like this video, please subscribe.